Hello everyone, you're all welcome for this lecture video. I am Sharath, working as an assistant professor in computer science department, Rajiv Institute of Technology, Asan. Okay, before to I recommend all of you to watch the program one video, NS2 program one video, so that it will be easy for you to understand the second program. So I strongly recommend you see the first video, then you go for the this one, second one. Okay, the program go like this: implement transmission of ping message or trace route over a network topology consisting of 6 nodes and find the number of packets dropped due to congestion. Here also at the end we have to find the how many packets has dropped due to congestion, and we have to build a network topology of 6 nodes. So what we have to transmit here, according to question, implement transmission of ping messages or trace route. So here in this program we are implementing ping messages. We are not going for trace route. Okay. Objective of this program is to understand the implementation of network topology consisting of n nodes or any number of nodes. Okay. Okay, before going to this topology or a program, first we should understand what is a ping command or what is that ping message. Okay, the full form of ping is packet internet grouper. It's a command that will be used to check the connectivity of the nodes in the network. Means whether the nodes exist or are active. If you want to check, then we will send a ping message. That message we call it as a ping message. That will, so basically ping command is used to check the connectivity of the nodes in the network. Okay, and one more point, and also ping command will be used to measure the time for a packet to travel from source to destination and destination to source. That is, we call it as RTT, round trip time, to and fro time. Okay, to travel from source to destination and the destination to source. Okay, that time we call it as round trip time. So ping mess command will be used to find the RTT. Okay, and here we have one more word, trace route. Here trace route command will be used to find the information about the route. Okay, so say for example, information about the route means, suppose if I want to travel from A to B node, okay, that is the route. From A to B I have to travel. Then in between A to B, how many number of hops are there, what are all the things we come across, all those things, route information we are going to get using trace route command. Okay, so we are here least bother about this trace route. Only we will concentrate on ping message. As mentioned, either ping messages or trace route. So we go for ping messages. So 6 nodes we have created. So before going to program, you should have this topology so that it will be easy for you to understand. So 6 nodes according to question: 1 2 3 4 5 6. See, node 1, that is n0, node 2 n1, node 3 node 4, node 5, node 6. Okay, so n0, here we have made a connection like this. So you remember this topology, it will be easy for you to understand the program. Okay, so as we know, the very first thing we should create a simulator object. This is how we are going to create set ns new simulator. Here simulator is a class, new is a keyword, ns is the simulator object, and set is the command. Okay, see, regarding all those things, already I told, I have explained in the program one video. That link I will give it in a description. Okay, you can go through that or refer that. This one, set ns new simulator. Then we have to open two files, network animation files and trace files. So this is how we will open set nf open. This is the file name we are giving. This is the file name lab2.nam, and in the write mode we are opening, and the content, this as a file descriptor it will work. This $nf we are attaching or assigning to the network this one simulator object. Okay, nam trace all, like that trace file. Okay, next, after creating simulator object and opening nam trace nam file and the trace file, so we are going to create a 6 nodes. This is how we all know how we create nodes. This is how we are going to create a nodes. So total 6 nodes, n0 to n5. Okay, any name we can give. After creating the nodes, we are creating a duplex link between the nodes, and we are setting the bandwidth, propagation delay, and we are mentioning the queue type. Okay, $ns duplex links we are creating from 1 to 0, 2 to 0, 3 to 0, 4 to 0, 5 to 0. Here 1 to 1 to 0, 2 to 0, 3 to 0, 4 to 0, 5 to 0. We are creating the link between the nodes, and any bandwidth you can give and any propagation delay you give, and the queue type we are giving as a drop tile queue. Any queue management algorithms you can use, we can use random early detection red or sred, stabilized red, dred, dynamic red, adaptive red, flow red. Any queue type management algorithm you can give here. Usually we will go for a drop tile. Okay, after creating a link, then we have to set the queue limit between the nodes. This is how we are going to set $ns set queue limit, from where to where you want to send, and what is the packet size. This represents the number of packet size. Okay, the explanation regarding all those things already I have explained in the program one. So if you go through that, it will be easy to understand all these things. So queue limit we are setting from 1 to 0, 2 to 0, 3 to 0, 4 to 0, 5 to 0. Okay, next, here the below code will be used to connect the ping agents to the node from 1 to 5. So we are going to create a ping agent, and that ping agent we are going to attach to the nodes. Okay, so that all the properties of this ping agent will be given to the nodes. Okay, set p1 new agent bar ping. Agent is the base class and this is the subclass ping. Okay, $ns attach agent dollar node 1 and ping 1. So ping 1 is the agent we are attaching to the node 1. Like that we create 5 ping agents, and we will attach to all the 5 nodes except 0. We are going to attach all the ping agents to the all the nodes. Okay, next, we are going to set the packet size and the time interval, that is data rate of the packets. Okay, $p1 set packet size, any MB you can give. Here we have given 500 MB. Then $p1 set interval time. Okay, in seconds it is going to take. After setting the packet size interval time, next we have to connect the ping agents. Okay, so here we are going to connect the ping agent p1 to p2. See here, p1 is nothing but n1 n2, means we are indirectly connecting n1 n2. We are indirectly connecting n1 n2, and p3 p4 we are connecting p3 p4, p3 p4. See, like this we are connecting. Then p5 p4, p5 p4 we are connecting like this. So we are all connecting the nodes. After connecting the ping agents, then we have to schedule the events. Here at the point one time we are sending a ping message. Okay, $p1 send. So the message is going to send. So as we send n number of messages, so that we will get the packet drops high. Okay, like in some interval of time we are in point 1 to point 5 we are sending p1 ping agent 1 message, then next 5 seconds we are sending second ping agent, like that for some amount of time you send, and by 2.0 time the it is going to finish all the events. Okay, next, here this is the important thing what you have to notice in this second program. Okay, the whatever so far we have discussed, all these things are similar to program 1 only. The only change in the program 2 is this one. These things is the only changes what you can notice in the program 2. See here we are create or we are declaring a procedure called as receive procedure. We call that procedure as instant procedure, and we are writing agent bar pin. It means that the meaning of this line is we the keyword in procedure will be used to, this is a keyword that will be used to define a member, this one or receive function to the agent and ping class. Okay, we are defining this procedure to this class agent and ping. This is the class, this is the name of the procedure, instant procedure, and it is this receive procedure is taking two arguments from and RTT. Two arguments it is taking, from which node and the round trip time. Okay, see here the name of the arguments you can give anything here, not only from or RTT. Okay, two arguments it is taking. Okay, first argument from which node. Okay, second argument and the round trip time. Here you can give a comma b also here. Then in the display message you can change like this, a b. Name of the arguments you can give anything, it will work. Okay, but usually we will give like this, from RTT. Here also from RTT. Okay, then the second line, dollar self instance variable node underscore. Note down here, dollar self, right? This acts as a this keyword or this pointer in the C++. The same functionality will be done by dollar self, and this node underscore is a variable. Which type of variable? Instance variable. Okay, we should be able to differentiate what is the local variable, instance variable, global variable. Okay, see this is the instance variable. Node underscore is an instance variable. In this node underscore is a variable, instance variable present in agent class. Okay, and this one put s, it acts like a printf statement in the C program. So we are going to display the message like node 1 node dollar node underscore space id. Okay, this will be replaced with the node number. Okay, these things will be replaced with node number, like node 1 received a reply from which node, like 2 3 like that, with the round trip time, and it will display in milliseconds. Some seconds value we are going to get. Okay, so these things you have to note down. Receive procedure, then we call the procedure finish. Here this is instant procedure receive, this is procedure finish. No arguments we are passing. We are declaring global ns nf tf, because outside it means that we are declaring this ns nf tf outside the procedure also. Then flush trace, close this tf and nf, and we are going to execute this nam file and exit of 0, stop, then run the simulation. Okay, $ns run, the simulation starts. Okay, this is regarding program 2. Okay, so the only change you have to notice is, so first you go through this you note down this topology. Then with respect to this we are going to name the nodes, create the link, set the queue size, and we will attach the ping agents. Okay, then you connect the ping agents. Okay, these are all the things common related to program one only. And also here you are going to schedule the events. Send means it is going to start sending the message, then it will finish. So finish procedure is also same. Only thing is this one, receive procedure, you should note down here. Okay, and awk script same. Okay, so we know $1 first field of the trace field, d if it is d, count plus plus. So everything remains the same as program one.